Hello, welcome to Chapter 3, homework questions 18 through 23 from section 312. Question 18, use the method from problem 3-2 to enlarge the shape below from the origin by a zoom factor of 4. I don't have the space to actually show all this, but what we want to do, remember in terms of the origin, we want to take each of those main kind of points, vertices, and go out 4 times where they're at. So for example, on this point right here, we can just call it A. It's at 2, 0. So we want to go from the origin 4 with the zoom factor of 4. So this already represents 1, a factor of 1. So we would go, this would be 2, this would be 3, and this would be 4. Now this represents 2 units, so all of these would be 2 units. So this point right here would actually be at 8, 0 on your graph paper. And so that would represent that one. And then we could do the same thing on the other side. So this would represent a factor of 1, a factor of 2, 3, and 4. And so then this would represent the point -8, 0 on your graph paper. And then for the point up here, we're 3 units away from the origin, so we're going to go, so this represents a factor of 1, so we'd go 3 units, 3 units, and another 3 units. So each one of these would represent 3 units. And so 3, 6, 9, 12 from the origin, so this would be at 0, 12. And then the last one, this point right here, at 0, 1, would also go 4, so that'd be 1, 2, 3, 4. So that'd be right there. So if I can kind of sketch this out, it would look something like this. And that would represent your new shape enlarged by a factor of 4. Question 19. The ratios Casey wrote from Part A of Problem 3-15 are common ratios between corresponding sides of 2 shapes. That is, they are ratios between the matching sides of 2 shapes. Part A. Look at the 2 similar shapes below. Which sides correspond? Write the common ratios using the side lengths. So the corresponding sides have to be in terms of the same location. So this is the side length where you can see this angle and the right angle are part of. So that would match up with this one. So 15 and 6 would be corresponding sides. We also have the base here of the triangle, if we're looking there. And that represents the same length as the base on the next one. So that means 20 and 8, those side lengths would be corresponding sides. And then also we have this one, the hypotenuse of each of those. Now those don't have any side lengths, but those would also be corresponding sides. We want to write common ratios using the side lengths as well. So let's write some common ratios for the side lengths that we do have. So there's a couple different ways. I'm going to match the blue side, so I'm going to say 6 over 15 would be equal to, and since I went from the smaller to the larger, I have to do the same thing, and now I'm going to go to the red side, and smaller is the 8 over 20. Another way you could do this is you could do 15 to 20 and 6 to 8. So we could also do 15 over 20 and 6 over 8. So you have a couple different options there in terms of how you want to write those common ratios that we've talked about. On Part B, find the hypotenuse of each triangle above. Is the ratio of the hypotenuse equal to the ratios you found in Part A? So on Part B, we want to go ahead and find the third side of the right triangle. So we'll take 15 squared plus 20 squared is equal to the hypotenuse squared. And then the short or the smaller one, we have 6 squared plus 8 squared is equal to the hypotenuse squared. So this would be 36 plus 64, which is 100. So if you take the square root of both sides, you get 10. And 15 squared is 225 plus 20 squared is 400. So that would be 625. And if you take the square root of that, you will get 25. And so now is that ratio going to be the same? So I'll just use, so we're all kind of on the same page here. I'm going to do the 6 over the 15, the 8 over the 20, and then now if I have this is 10 and this is 25, then let's see here, that would be 10 over 25. Do those all reduce to the same ratio? So 6/15, if you divide both by 3, that would give you 2/5. 8 over 20 divided by 4, that would give you 2 over 5. And then the last one to check, if this one you divide by 5, you get 2 over 5. So yes, is the ratio of the hypotenuse equal to the ratios you found in Part A? Yes, they are. We've simplified them, and you can now see that. Question 20. Are the lines represented by the equations below parallel? Support your reasoning with convincing evidence. So we'll go ahead and graph the first equation, blue. Y is equal to negative 3/5 x plus 2. So we have the y-intercept, and then the slope is negative 3. So we're going to go down 3 and to the right 5. And we can do that a couple of times. We can also go up 3 and to the left 5. Just make sure one of the numbers represents a negative. That's, you can see the line will be decreasing. And since we're going to graph 2 of these lines, we need to make sure that we are labeling what each of the lines are. And I'll also use color to show that as well. The next one is negative 3/5 x minus 3. So our y-intercept is at negative 3. But you'll notice our slope is the same. So I'm still going down 3 and to the right 5, or up 3 and to the left 5. And then when I graph this line, you'll notice that it appears that these two lines do not intersect. So are the lines represented by the equations below parallel? Yes, they are parallel. How do we know that they're parallel? We know they're parallel not from the graph, but from the slopes. So the slope of the first one is negative 3/5, and the slope of the second one is negative 3/5. So they're decreasing at the same rate, so therefore they're never going to intersect. So once again, make sure you're answering the questions as to what they're asking. So are the lines parallel? Yes, they are parallel. And once again, support your reasoning, and we said because they have the same slope. And so I just added on to the bottom there in terms of making sure we're answering the question. Question 21, multiply the expressions below, then simplify if possible. So once again, you get to determine how you want to do this. We can use the distributive property, or we can use the generic rectangle. So the first one, I'll use the distributive property. 2x times 3x is 6x squared, and then 2x times 4 is 8, so that's minus 8x, and those are not like terms, so we cannot combine them. On B, I'll show you the generic rectangle method. X plus 3, I'll just put that one on top. It doesn't matter though. And then 2x minus 5 on the side. 2x times x is 2x squared. 2x times 3 is 6x. And what we're doing is we're just finding the area of each individual rectangle, and then we'll combine them, and you'll notice that these two terms are like terms, so we'll add those. So we get 2x squared plus x minus 15. Just make sure if you are using the generic rectangle that you are answering the question and that you're not just doing the generic rectangle and stopping. Part C, I will go ahead and do the distributive property. So this is 2x times 2x, so that's 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is positive 10x. And 5 times negative 5 is negative 25. And when you go to combine these like terms, the 10x and the negative 10x cancel, and you're left with 4x squared minus 25. And you might have recognized that because it is the same binomial, except one is a positive 5 and one is a negative 5. So you notice that your middle term cancels. Now on D, we actually have three things that are being multiplied together. So just a quick reminder, if you have 2 times 3 times 4, you can't magically multiply all three of those numbers together exactly at the same time. You might take 2 times 3 first to get 6. 6 times 4 is 24. All right. You could also, multiply in different ways. You could take 3 times 4 is 12, and then 2 times 12 is 24. But you can't multiply all three of them together at once. So the same thing applies when you're dealing with expressions. So however you want to handle this, we can do multiply two of them together and then multiply the the product of those, and the next one. So I'll just, let's see, I'll just distribute this, and then I'll use the box method. So 2x times x is 2x squared, x times 1 is x. Then I'll use the generic rectangle to multiply my two binomials. So now we'll create this, and I'll make the top 2x squared an x, and then the left-hand side x minus 3. So now when we multiply, we get 2x cubed, because x squared times x to the first. X times x is x squared. Negative 6x squared, and then negative 3 times x is negative 3x. And it looks like we do have like terms once again on the diagonal here. So we'll combine those, and our final answer will be 2x cubed minus 5x squared minus 3x. Question 22, examine the relationship in the diagram below, then solve for x and y if possible. Justify your work using angle relationships. So we notice that we have two parallel lines, all right, cut by a transversal. So we can use vertical angles, which means these two are congruent. We can also use corresponding angles, which means this one, the 5x plus 11, is corresponding to the y value, which means those are also congruent. So let's go ahead and can we use that to figure out the x? Well, let's write that down, and then we'll go from there. So we have 5x plus 11 is equal to y. So there's two different variables, so we'll have to kind of figure out how to do that. We also know that these two angles that are formed right here are a straight angle. So we also know that y plus 119 degrees is equal to 180. So we know this because of straight angles. And we know straight angles are supplementary. So if we subtract 119 from 180, that would be, what, 61 degrees? So we know y is equal to 61 degrees. Now we can use that and our corresponding angles to answer the x. So we have 5x plus 11 is equal to y, which is 61. And up here, we got two plus signs for some reason, so let me fix that. It's 5x plus 11. All right, and then now we can subtract 11 to both sides, and that'll give us 5x is equal to 50 degrees, divide by 5, and x is equal to 10 degrees. So we knew this one because of corresponding angles, and corresponding angles are congruent when you have two parallel lines cut by a transversal. So x is 10 degrees, y is 61, and then here's our justification. Question 23, read the following statements and decide if, then combine, or when combined, they present a convincing argument. You may need to refer back to your shape toolkit as you consider the following statements and decide if the conclusion is correct. Be sure to justify your reasoning. Fact number 1, a square has four sides of equal length. Okay, so keep that in mind. A square has four sides of equal length. Fact number 2, a square is a rectangle because it has four right angles. All right, and then the third one, a rhombus also has four sides of equal length. So fact 1 and 3, a square and a rhombus both have four sides of equal length. So the conclusion is, therefore, a rhombus is a rectangle. So is that true based on the three facts? Is a rhombus a rectangle? Well, a square has four sides of equal length, so take that, all right? A rhombus also has four sides of equal length. So is it true, since a square is a rectangle because it has four right angles, does that mean a rhombus would also represent a rectangle? Does it have four right angles? And the answer to that is no. You know, a rhombus will have the parallel sides, but the angles right here are not right angles like a square is. So therefore, a rhombus is a rectangle is not convincing. It's not true. So all of the facts are correct, but the conclusion is not based on the facts alone. So once again, even though a rhombus has four equal sides, it does not have four right angles, and therefore is not enough evidence to say that a rhombus is a rectangle. So I'm not going to write all that down, but just make sure as we kind of talk through this, justify that reasoning as to why you know that this is not enough information, or based on the facts that are given, we cannot make the conclusion that a rhombus is a rectangle. So once again, make sure you justify why this is not convincing because, and then write what you need to make sure you are clear as to why it doesn't work.